All right, section 3, here we go. Let's talk about acid rain a little bit. So acid rain. Acid rain is caused by sulfur dioxide and nitrogen oxides that react in the atmosphere with water to produce the acid rain. The thing about these chemicals is that they can travel long distances before they get back to the Earth's surface, and so they cause regional problems, not just local ones. So acid rain, or it's acid deposition actually, but the common term is acid rain, but in reality it can fall as many things like acid fog or acid snow as well, so we don't limit it to just acid rain. It's not like if you're in the middle of acid rain either and it falls on you, you're going to burn your skin. We're not talking about those high levels of pH. So typical rain falls about 5.6, has pH above 5.6. Acid rain usually is 4.4 to 4.7, so it's not a vast difference in pH, but it's enough to cause some real problems. And so what happens is we burn things in the form of fossil fuels. That stuff arises into the atmosphere, either from smokestacks, cars, whatever it may be. It combines with water in the atmosphere and forms sulfuric and nitric acid that then get blown or moved around and fall back to the earth in the form of precipitation, fog, rain. And then it has an effect on the environment. And the effects vary. If you have deep lakes that are in limestone-rich areas, then those lakes are buffered and they don't usually suffer from pH problems because the limestone reacts with the acid and breaks it down. If you're in a shallow lake that isn't exposed to limestone, then we can have real severe problems with acid rain. You can kill the lake. So it varies depending on the situation. By the way, nice big tall smokestacks like we have in Wyoming usually help reduce local air pollution quite a bit, but what they do is they increase the whole regional air pollution. So something to watch out on. It doesn't go away just because you push it higher into the air. This map's actually a pretty good illustration of where acid rain's happening. So if it's green on here, the acid rain pretty much doesn't exist. So North Dakota, South Dakota, Nebraska, there's not much acid rain in those locations at all. Over here on the East Coast, you see that we have our severe problems. The biggest one in this area is Billings. Billings produces enough stuff because of its refineries that it causes some local change in precipitation. But back east where we have a lot of industrialized factories and stuff, we see really high levels of acid rain, relatively speaking, and it creates lots of problems. Here are some of the problems it can create. So aquatic ecosystems can be affected pretty negatively. Here's a picture of a lake down here that's kind of dead as a result of its pH changing. Loss of crops and trees. You can see the trees in the background, but crops are also suffer as a result of it. Can leach out soil nutrients. So the soil nutrients would stay in place if it was just water, but the increased acidity breaks it off from the soil and helps wash it away, which can then hurt the soil long term. It causes human respiratory irritation, which is a problem, and it can release toxic metals. Metals react with acid and turn into gas and a bunch of other things, and so having that in there can really change the amount of metals that are being released from soils. And then, of course, they can damage statues and monuments, like this picture here is an illustration of that. And so that process doesn't just end with the emissions turning into the acid rain falling to the ground, but it can leach and it can kill trees, it can cause drought, you can lose insects, it can change the nutrients underground, it can cause root damage, it can then infiltrate into groundwater and lakes. And so because it's part of the water cycle, it moves around quite a bit. So what do we do about it? Well, there's either prevention or cleanup. From a cleanup perspective, there's not a lot of choices. We can add lime, which is a base, to lakes that have suffered as a result of this to neutralize the problem there. And we can add phosphorus fertilizers to neutralize it as well. But those create their own problems and have their own issues. And so the best way to do is prevent it. And so we can use less coal. We can burn better coal. We can increase natural gas use, which would decrease the use of coal. We can use more alternative energies or renewable energies. We can remove SO2 particulates and NO from smokestack gases with scrubbers and things like that. We can remove it from automobile exhaust with like a catalytic converter. We can tax the emissions of those things, and we can create more energy efficient cars, are all ways to improve this problem. All right, end of this section. Bye-bye.